spherical mirror formula and sign convention. Now, say for concave mirror, and convex mirror, what is the formula relationship between focal length and radius of curvature? For spherical mirror, focal length for both the mirrors is half the radius of curvature. This we have studied. Focal length is half the radius of curvature. So focal length of a spherical mirror, focal length of a spherical mirror depends only on the radius, and this focal length f is independent of, it does not depend on number one, wavelength of light, that is whether it is red color, blue color, it does not depend on which color of light is falling on the mirror. It does not depend on the medium. It does not depend on the medium, whether it is air or water. It only depends on the radius of curvature. So focal length is independent of the wavelength and color of light. It does not depend on which color of light you have taken. And it also does not depend on the medium. Focal length only depends on the radius of curvature. Now, for a plane mirror, if you take this concept to a plane mirror, if you take this concept for a plane mirror, what is my radius of curvature, children? Radius is infinity. For a plane mirror, my radius is infinite. What is my focal length? Focal length is r by 2. So it is also infinite. So remember, if you have a plane mirror, we say if a sphere has infinite radius, like the earth, children, the earth is so big that a small part of the earth appears as a plane. So when a sphere has infinite radius, it appears as a plane, infinitely big radius. So when you have a very, very big sphere, a little part of it can be treated as a plane. So plane mirror has radius infinite, focal length is r by 2. So remember, for a plane mirror, your focal length and radius is infinite. Now today first we are going to learn the spherical mirror formula. Now, concave, we can assume two cases where we get real image and we also get virtual image. In concave, you can get real image, you can also get virtual image. But in convex, there is only one option. you will only get a virtual image. You will only get a virtual image. Now, say this is your concave mirror. Pole, focus, center of curvature. Concave mirror, pole, focus, center of curvature. This is your convex mirror. Pole, focus, center of curvature. Now, when do you get a real image? We get a real image, children, when the object is at infinity, beyond C, at C, between F and C. From infinity to F, we get a real image. But when do we get a virtual image? We get a virtual image when the object lies between the pole and the focus. When the object lies between pole and focus, we get a virtual image. For convex mirror, the object always produces a virtual image. Now, here if we draw the ray diagrams, a ray parallel will pass through focus and a ray through the center of curvature it is the normal ray. It will go and retrace its path. That is my object, and here you get my image. It is a real image. You get a real image. For virtual image, what is the ray diagram? A ray parallel to the principal axis. After reflection, will pass through focus, and a ray through the center of curvature will go and retrace its path. When these two rays are extended backward, when these two rays are extended backward, here you get the virtual image. So, in concave mirror, you get both real and virtual image. Real image we get when the object is from infinity to F, and virtual image we get when the object lies between P and F. Now for convex mirror, a ray parallel to the principal axis will be reflected in such a way that when extended backward, it passes through focus. And a ray which was coming towards the center of curvature, a ray which was coming towards the center of curvature will come to the mirror and retrace its path. Now where the two rays intersect, there you have a virtual image. Now, from the pole to my object, this is my object, this is my image. Here this is my object, this is my image. Here this is my object, this is my image. All distances should be measured from the pole. So, points to remember, children. Number 1, all distances should be measured from the pole. Next, pole to object, the distance from pole to object is called object distance u. We will denote the object distance u. The distance from pole to image is called the image distance v. The distance from pole to focus is called focal length f. So, pole to object, this distance is your u. PO is u. PO is u. Pole to image, that is PI, is called V. Pole to image is called V. PF is called focal length f. Now, we have a mirror formula. The mirror formula tells us 1 by V plus 1 by U is 1 by F. The mirror formula tells us, children, 1 by V plus 1 by U is 1 by F. What is V? V is my image distance, U is my object distance, F is my focal length. Now here, let us check whether the formula is correct. In a plane mirror, what is my focal length? Focal length is infinity. Let us check for a plane mirror. Now for a plane mirror, focal length is infinity. So if you put the formula 1 by V plus 1 by U is 1 by F, here focal length is infinite, therefore 1 by V plus 1 by U is 1 by infinity. And what is 1 by infinity? 0. Therefore, 1 by V plus 1 by U is 0. Therefore, 1 by V equal to minus 1 by U. Now, if you cross multiply, V equal to minus U. Now, what does this tell us? That if you have a plane mirror and if you have an object, then if this distance is 1.2, then the image will also be 1.2 centimeter behind. This is my object. This is my U. This is my image V. So this is what we learn, children. What did we learn? For plane mirror we know image is as far behind the mirror as the object is in front of it. So, my formula is correct. This is what we know. Therefore, we assume the formula which we did is correct. We have verified that this formula is correct because when we have applied it for a plane mirror whose focal length is infinite, I told you for a plane mirror the radius and focal length is infinity. 1 by infinity is 0, so you get V equal to minus U. So this is what we know. Image is as far behind the mirror as the object is in front of it. So this formula is correct. Now, next part which we have to know is the sign convention. Now there are different sign conventions, but we are going to use this one. Say you have going from pole to object. Now light is incident. Light comes from the object. All distances should be measured from the pole. Now when you go from pole to object, you are going against light. When you are going against light, then that distance is taken as negative. That distance is taken as negative. So in sign convention, if we go against the direction of light, we consider it negative. And if you go in the direction of light, then we consider that distance positive. Now look here, children. Always start from pole. Go from pole to object. Go from pole to object. So PO in this case, you are going against light. Object distance is U. So it is minus u. Go from pole to focus. You're going against light. Always go from pole. So PF is minus F. PI. Go from P to I. Again you're going against light. Light always comes from the object. So Pi in this case is minus V. Now come here. Pole to object. You're going against light. So PO is minus U. Pole to focus. Against light. Always go from P. Now pole to image. Now your light is coming from the object. Pole to image. You're going in the direction of light. So in this case, Pi will be plus V. Image distance is V. Come here. Here, pole to object. You're coming against light. Light will always come from object. PO, you're coming against light. So it is minus U. Pole to focus. Light is coming in this direction. This is the direction of light. Because light comes from the object. Light comes from the object. Pole to focus. Here is plus F. Pole to image in the direction of light is plus V. So, sign convention is very important because you have to apply the sign conventions in your formula while doing sums. Now, what are the sign conventions? Number one, always you are going to start from pole. You are going to consider light coming from the object. In this case, this is the direction of light. Here, where is the object? This is the object. So, this is the direction of light. Here, where is the object? Here. So, this is the direction of light. Now, always go from pole. Now, pole to object. You're going against light. Object distance is U. So, minus U. Pole to image. Against light. Minus V. Pole to focus. Against light. Minus F. But here, pole to image. You're coming in the direction of light. So, that is positive. So, in this formula, while we do sums, we will put the sign convention. Now, let us look into some graphs from this formula. If you are given a graph to plot, you can be given two graphs to plot. The first graph, you are given, say, you are given to plot 1 by V and 1 by U. In the second graph, you are given to plot V and U. Now, what is the formula, mirror formula? 1 by V plus 1 by U is 1 by F. When 1 by u is 0, then what happens when this term is 0? Then 1 by v becomes equal to 1 by f. So when 1 by u is 0, then this point is 1 by f. Here 1 by u is 0. Again, when 1 by v is 0, when 1 by v is 0, then 1 by u becomes 1 by f. Where is 1 by v 0? So if this length is 2.5, so I measure 2.5 over here. Actually this length is 2.67. So if you measure 2.7 over here, this is 1 by f. Why? Because at this point 1 by v becomes 0. The graph will be like this. Now, if you plot a graph of 1 by v and 1 by u, you know if 1 by u increases, 1 by v will decrease because focal length does not change. The sum of two will remain the same. If 1 by u increases, 1 by v will decrease because sum of the two will remain the same because focal length of the mirror is constant. When 1 by u is 0, when 1 by u is 0, 1 by v becomes equal to 1 by f. Then 1 by v becomes 1 by f. And when 1 by v is 0, where is the y? This is plotted along y-axis. This is plotted along y-axis. And this is plotted along x-axis. Now y is 0 on the x-axis, isn't it? Y is 0 on the x-axis. So when 1 by v is 0 at this point, then the value of 1 by u becomes 1 by f. So the graph of 1 by v and 1 by u is this one. Now, if you are asked to plot a graph of v and u, let me mark here. Say this is f, this is 2f, and here again I mark f, 2f. Say this is f, this is also f. So this point is f, this point is 2f. This is f, this point is 2f. This is f, this point is 2f. What is twice the focal length, children? if you go and get it in your mirrors, P to F, this is your focal length, right? This is your focal length. And what is 2F? 2F is your radius of curvature. 2F is your radius of curvature, right? Now, tell me one thing. When object is at infinity, where is your image? Your image is at focus. So, you can write here, point number 1, when object distance is infinity, your image is at focus. So, when u is infinity, v is f. Now, infinity means it will not touch the y-axis. So, when your object is at focus, children, your image is at infinity. We know when the object is placed at focus, then the image is at infinity. So when the object is at infinity, image is at focus. And when the object is at focus, image is at infinity. Now, if I come to draw the graph, how will the graph look like? Your graph will be something like this. It will be something like this. Now, what does it tell us? It tells us that when object distance is f, image is infinity. That means the graph will be something like this. When object is at focus, your image distance is infinite. Means it should not touch the f. When object is at focus, image is at infinity. It is at infinity. Now, when object distance is 2f, children, image is also at 2f. We know when the object is at center of curvature, image is also at center of curvature. So this point will be common. And this will be the graph. So when object is at infinity, image is at focus. And when object is at focus, image is at infinity. So this is my object distance. When object is at focus, image is infinite. It is very, very far. Very, very far. When object is at infinity, the image is at focus. So when object is at infinity, very, very far, the image is at the focus. Now where the 2 points intersect, this point, your object distance is 2f, image distance is 2f. This is 2f comma 2f. Now which is this point? If you come here, children, when the object is 2f means it is at the center of curvature, then the image is also at the center of curvature. So from the beginning, if we recap, children, this is the introduction. After this, we are going to do sums. Now, focal length is r by 2. Focal length is independent of wavelength of light and color of light. If blue light comes, red light comes, doesn't matter. Focal length is independent of the medium, whether the medium is air, water, whatever it is. For a plane mirror, the radius of curvature is infinite. Focal length is r by 2, it is also infinite. For concave mirror, you get both real and virtual image. When the object comes from infinity to f, you get real image, and when the object lies between p and f, you get a virtual image. For convex mirror, image is always virtual. Now all distances should be measured from the pole. Always measure all distances from the pole. The distance from pole to object is my object distance u. Distance from pole to image is my image distance b, v. Distance from pole to focus is my focal length f. My mirror formula is 1 by v plus 1 by u is 1 by f. We can check this for a plane mirror. For a plane mirror, my focal length is infinity. If you put f as infinity, 1 by infinity is 0. 1 by v plus 1 by u is 0. 1 by v equal to minus 1 by u. V becomes minus u. That means the object and the image, they are in opposite direction in equal distance apart. So the formula is correct. Next we come for sign convention. Go from pole to the point which you want to measure. If you are going against the direction of light, we consider the distance negative. If you are going in the direction of light, you consider the distance positive. If you are asked to draw a graph of 1 by v and 1 by u, it will be a straight line. When 1 by u is 0, 1 by v value becomes 1 by f. And when 1 by v becomes 0, your 1 by u becomes 1 by f. If you are asked to plot a graph of v and u, here you are asked to plot a graph of v and u. We know when object is at focus, image is at infinity. And when object is at infinity, object distance is very far, it will not touch, image is at focus. And when object is at 2f, that is center of curvature, image will also be at center of curvature. When object is at 2f, image is also at 2f. Now, if by chance you are asked to write an expression for magnification, if you are asked to write an expression for magnification, then you are going to write magnification m. Magnification m is image height by object height. And this formula you are going to put minus v by u. Magnification is image height by object height, and the formula you are going to give is minus v by u.